Hello there, person on the internet, and welcome to this Autodesk Inventor PC advice hardware workstation buyer's guide. Look, if I'm honest, I haven't actually got a title for it, but it doesn't matter. It's not important. The story is the Autodesk Help blog team approached the expertly community asking for people to write some articles for tips and tricks to release on a monthly basis on their website. And I thought, you know what, mate, I can do that. It's not a problem. Tips and tricks is my thing. That's what I do. I can do them in a coma. It's not a problem, mate. But then it got me thinking, most of the tips and tricks that I know about, I've already done them on my YouTube channel. It would be a bit lazy to just regurgitate them straight over here. So I thought I'll do something a bit different, something that I'm interested in right now. And that is PC hardware benchmark testing of Inventor on different types of systems. But then that opened up an entire can of worms, because what I wanted to do was a hardware buyer's guide for this article. But it was just far too complicated. There was too many different circumstances to take into account. There's no one rule fits all people in workflows. Each recommendation splits off into multiple ifs and buts, which require different explanations per component type. What's the difference between a Xeon and an i7 and a Quadro and a GeForce and a Radeon and a FirePro and ECC and solid state drive? There's too many things to try and cover in one piece of content. So instead, what I thought I'd do is do a direct comparison between two systems that you would think are on completely different opposite ends of the scale for performance, and then show you how they perform. Now, there'll be people out there, and I guess these are the people that I'm aiming this at, that are thinking to themselves, well, hold on a second then, hold on a second.
Hold on a second there, cool your rainbows, my pony friend.
Why is there even a discussion to be had here? Surely all I need to do is raise capex and then place a purchase order with Dell or HP for one of their precision workstations or their Z workstations, their 3D CAD specialist workstations, because that's what my CAD supplier would tell me to do. Each of these workstations, they're ISV certified, they're mission critical, scalable, reliable performance for graphical intensive applications, blah, 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 blah. Surely that's all I need to buy. Pre-configured workstation, and that'll suit my needs absolutely perfectly and better than anything that you can show me, Neil. Well, yeah, that's just not the case. It's just not the case. And the whole point of this video is to show you that. So, with that in mind, I have two systems to test. I have in one corner a 1 year old. So this was bought only 1 year ago. It was actually bought for a real world engineering office, a global manufacturing company. It's a Dell Precision T5610 workstation, and inside it has an Intel Xeon. So it's proper professional workstation. It has an Intel Xeon 6-core processor with hyper-threading, so it's 12 logical threads at 2.1 gigahertz, turbo clocks up to 2.6 gigahertz. It has 8 gig of DDR3 ECC RAM. It has an NVIDIA Quadro, so it's professional graphics, Quadro K4000 graphics card. It has at the time it was recommended by Dell to the guy that bought this. It has a Seagate Barracuda internal 500 gig mechanical hard disk as well. Now this workstation, this Dell T5610 workstation, was bought 1 year ago for the princely sum of $3,500. That's 3,000 English pounds. That's not cheap at all. In the other corner, we have basically, what's just happened is I've changed my mind on how I was going to structure this video, sort of mid-filming. What I was going to do, after explaining the specs of the Dell Precision, is I was then going to show you what the specs of the other PC are, and then show you the benchmarks. But I thought, you know what, I think the video might have a bigger impact and might explain the point more if I showed you the benchmarks first, and then showed you what PC the Dell was being compared against, because then that'll kind of reinforce and bring the point back home a little better. So that's what I'm going to do. So up next to the benchmark tests, what you're going to see is some of the clips are going to be time-lapse. They're going to be sped up quite significantly. Some of them went over 40 minutes, so you're not going to really sit through that, so I've sped them up quite considerably. It's all going to go pretty fast, but you should, if you can pause it, you get the gist of it. But anyway, here we go. Here's the benchmarks.
possible.
Welcome back from the results. Right, this is the part where I do a little bit of waffling. We'll discuss the results, draw some conclusions, and talk about what we've just seen. So, what have we just seen? Well, the Dell Precision Workstation with its $3.5 grand invoice, its Xeon 6 cores and 12 threads, its ECC RAM, its professional Quadro K4000 graphics card, and its mission critical blah 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 blah. It was walloped. It was thumped. It was clinically smashed into next week by the mystery PC. But what it's worth noting as well is that there was a wide variety of tests performed there. There was single-threaded workflows, there was multi-threaded workflows, there was drawing view calculations, there was mass migration of data set, there was opening of different sized real-world assemblies, there was FEA meshing, FEA result solving, a whole different variety of tests that use single-threaded and multi-threaded workflows. And the mystery PC beat the Dell across all of those tests. Now, that's really quite interesting. So what kind of PC was the mystery PC? What kind of PC can beat a 6-core Xeon in multi-threaded workflows? It's got to be a monster, hasn't it? It's got to be a very powerful PC. Am I leading you up to something that you should absolutely, definitely buy? Well, we shall see. So, what kind of PC is the mystery PC? Well, if you're familiar with my TFI CAD Tips channel, you will have seen this PC already featured on the channel. It's my budget PC in the cube case. Yeah. So, if you don't watch TFI CAD Tips and you've never seen those videos, you'll have no idea what I'm talking about and you'll be like, dude, what? What is this PC? I have no idea, it's just a black box. Right. Okay. Before I mention what the specs of this PC are, I just need to make a point of noting that the benchmarks were performed on as much of an even platform as possible. Both PCs were running a fresh version of Windows 10. Neither PC had antivirus or firewalls installed. Neither PC had any junk installed. It was just a fresh version of Windows and the CAD software. Both PCs were running at 1080p. Inventor was 2017 hotfix 1, build version 142, I want to say. and the application options in Inventor were identical across both PCs. They were as even as I could possibly make them. Okay, just have to get that out of the way, because there will be some people that go, yes, but you didn't mention that. I can't mention everything. I can't mention everything. Right, the specs of the Cube is, it is a cheap budget PC built on a shoestring. It was built for one purpose and one purpose only, to be as good at Inventor as it can possibly be. Knowing what Inventor requires out of hardware, I built a PC specifically for that purpose, and it looks like it's come up trumps again. It has inside it an Intel Pentium 2-core, no hyperthreading, G3258 processor clocked at 4.2 GHz. Yes, a 2-core Pentium with no hyperthreading has beaten a 6-core Xeon at multi-threaded workflows in a 3D CAD application. You've just seen that, which goes to prove, and this is, I guess, the first conclusion from this video, is that with Inventor, even for the modules that use multi-core, clock speed is still far more important than number of cores. If you're buying your next PC, make sure you go for clock speed. Just forget about how many cores it has. You want to go for clock speed. It also has 8GB of RAM, the same as the Dell Precision Workstation. It has a cheap budget, sort of quotes, get the job done RAM, which was non-ECC, but it's entry level 8GB stick of RAM. It has a solid state drive in there. It has an entry level SATA 3, I think it's a crucial 256GB solid state drive in there. It had a gaming graphics card in there, which was quite a low end, sort of low to medium range AMD R9 380 graphics card. And in total, I guess another headline stat is that the cheap PC in the Cube case, the total sum of all the parts came to $550 US, as opposed to the Dell, which was $3,500. Another interesting statistic is that the Quadro K4000 graphics card in the Dell retails at around about approximately $1,000. So that entire PC cost half of just the graphics card of the Dell. So what am I saying? Neil, what are you saying? Neil, are you saying that we should all us engineers, all us draftsmen, we should go out and buy our own PCs? We should assemble our own PCs on a really cheap budget, buy crap, because that'll be better than a professional workstation? Neil, is that what you're saying? No, I'm not saying that at all. No, what I'm saying, the moral of this story, and I guess the whole point of this video, is to prove, and hopefully I have proved, that it is worryingly easy to go to somewhere like Dell or HP, accept the first thing that they give you, and it's got, even though it's got a precision badge or a Z badge on it, a Xeon and a Quadro badge on it, it is extremely worryingly easy to buy something that is totally unfit for purpose if you don't know what it is that you're buying. So what you want to look for in your next workstation is high clock speed, and you want a solid state drive as well. Quantity of RAM doesn't make your PC run any faster. Really want to stress that point, because I see it so many times. My PC's slow, I need more RAM. No, you don't. No, you don't. More RAM does not make your PC go any faster. It gives you more capacity to work on bigger data sets. It doesn't make your PC run any faster. 32GB of RAM just means you probably got maybe 25GB of RAM free doing nothing. It doesn't make you, that extra RAM doesn't make anything go any faster. Anyway, so you want to go for a really high clock speed CPU. Now, just another point about that. What I will recommend is that you do definitely go for a workstation. Go for a professional workstation. Just because I've discredited in some ways this particular unit here that I have in my office does not mean in any way that professional workstations are bad. They are not. This one was just picked wrongly. It had the wrong spec. You want to go for a workstation that has a high clock speed Xeon in it. You want to go for something at a minimum 3.5 GHz. So you want to go for around about 4 to 6 cores. You want to go for a clock speed of around about 3.5 GHz within budget. I know different people will have different budgets, but you want to stick to a high clock speed. Clock speed is king when it comes to Inventor. You hear that said a lot, but hopefully seeing it in this video kind of just drives the point home. In terms of RAM, there's no hard and fast rule. It depends on the size of the data sets that you work with, but you want to go for approximately, I would say, 12 to 16GB of RAM at a minimum. I've got 8GB in these two, but the data sets were still relatively small. If you work on bigger assemblies, you want to go for more RAM. You want to go for somewhere along the lines of about 32GB of RAM. For your graphics card, to be honest with Inventor, it doesn't matter these days. You want to go for a minimum of Quadro. Well, we're at the Maxwell range of graphics cards for the Quadros at the moment. You want to go for an M2000 or an M4000 Quadro. If you can't afford, or if you can't put in an M range graphics card from the Quadro range, you want to go for a K2000 or a K4000 or 4200. For your hard disk, you absolutely categorically want to go for a solid state drive. OEMs like Dell and HP should not, and I mean this, they should not be selling PCs with mechanical hard disks in this day and age. They bottleneck your PC to something rotten. You should not be buying a mechanical hard disk. You want to go for a solid state drive. Ideally, go for a PCI Express or an M.2 solid state drive. Inventor doesn't see the benefits of a high-speed solid-state drive. It doesn't read or write to the disk fast enough to benefit from that kind of a high-end drive, but you'll see the benefits of that kind of a drive over your other workflows that you use throughout your working day. So anything else that you do, like bulk file copies, database applications that you use, anything else, multitasking, you'll get benefits of a high-speed solid-state drive. Inventor won't use the high speeds of a solid-state drive, but it will benefit from a solid-state drive over a mechanical drive. You've just seen that in these tests. Look at the boot times. The boot times were ridiculous on the Dell PC as opposed to the cheap Cube PC. So that's pretty much it. That's all I've got. Hopefully, this just goes to prove. And again, I'm not saying go and buy this PC. Do not go and buy a 2-core Pentium and put it in your drone office. That would be a bad move. But on the same note, don't go and buy the first Dell or HP PC that you see. You need to know what you're buying, and you need to have some kind of awareness as to what you're buying. If someone provides you with the spec, if your CAD supplier or your IT supplier provides you with the spec, you need to be able to check over that spec and make sure that you're buying something that's fit for purpose. High clock speed, solid state drive are the two most important things. Graphics card, still go for a Quadro or an AMD FirePro. In terms of the prices, if you think, well, yeah, but the Dells are overpriced, they're not really overpriced. With Dell or HP, you're buying from a trusted brand. You're buying from somewhere that you know you can rely on their support if things go wrong. If you build your own PC and something goes wrong, then you're kind of in trouble. The same for these custom system builders. There's a lot of custom system builders out there that'll provide you with a pre-built PC using consumer-grade components. i7s, GTX 980 Ti's, and they're very powerful PCs. But if something goes wrong, they may offer some kind of next-day support. But is that supplier going to be around forever? You just don't know. It's a risk, and in business you want to minimize risks as much as you can. That's why Dell and HP are the professional choice. So always go for a professional workstation, but just make sure you pick the right components for the job. So with that being said, thank you very much, guys. Thanks to Autodesk for asking me to do this video. Hope you found it useful, and I'll see you over on TFI CAD Tips. If you haven't been there already, we do CAD Tips. Right, I'll see you next time. Thanks.